Let's look at proposition number 19 of book 11 of Euclid's Elements. The proposition says, if two planes which cut one another are at right angles to any plane, then their intersection is also at right angles to the same plane. So here you have two planes, let's say AB and BC, and they cut each other at BD. If these two planes are at right angles to the plane of reference, then the line of intersection BD between these two planes is also at right angles to the plane of reference. You might have already noticed that AD is the intersection of plane AB and the plane of reference. CD is the line of intersection between the plane BC and the plane of reference. Okay, now how do we prove this? Let's assume that this line of intersection between these two planes, BD, is not perpendicular to the plane of reference. Now, if it is not, there must be some other line which is perpendicular in this plane and some other line in this plane which is perpendicular to the plane of reference, because this is the only line which is common to both. So if this is not perpendicular to plane of reference, there must be some other line. So let's draw these lines. So let's say we have DE, which is perpendicular to the line of intersection between the plane AB and the plane of reference. Similarly, we have a line DF which is perpendicular to the line of intersection between the plane BC and the plane of reference. That means AB, the plane AB, is perpendicular to the plane of reference, and DE, which is in AB, is perpendicular to the line of intersection AD. That means DE is also perpendicular to the plane of reference. Similarly, DF is perpendicular to the plane of reference. Why? Because again, plane BC is perpendicular to the plane of reference, and DF in the plane BC is perpendicular to the line of intersection between these two planes. So we can say DF is perpendicular to the plane of reference. But is that possible? It is not. Why? Because we have ended up setting up two lines from a point in the plane of reference, two straight lines, DE and DF, which are perpendicular to the plane of reference. And as we have seen in one of our previous propositions, that is not possible. So because of this impossibility, our assumption was wrong, that BD is not perpendicular to the plane of reference. So we can say that if two planes cut each other and are at right angles to a plane of reference, then their intersection is also at right angles to the plane of reference. And just to give you a animated this one, it doesn't matter what the angle between these two planes are, planes AB and BC. Their line of intersection will always be at right angles to the plane of reference. If these two planes are also perpendicular to the plane of reference. So that is proposition 19 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.